Welcome to the second presentation of the quality chapter, Quality Management and Statistical Process Control. In this second presentation of this quality management part of the course, chapter 4, I will talk about the evolution of quality and quality management. I want to show you how quality evolved over the years, and basically it is still evolving today, and new things will become available. I'm sure when you're working in companies, you may see that some new tools, some new ways of dealing with quality are being introduced. But let's have a look at the early years of quality management. What happened with quality management in the beginning? Now, quality is not new. We know quality over many years, over thousands of years, because people have been doing things and they have been creating a kind of quality. They created products or drawings or whatever that they wanted to be proud of. Now, when you look at older things like older silverware or products, you may find that these contain stamps or labels. And those stamps and labels relate to the person who made these. There were organizations that were giving labels to craftspeople. So basically, you can find the person who was making certain products at that time. We know the Fabergé eggs. We know some very famous goldsmiths, people creating pieces of art. They wanted to show to the people that their product was of high quality, and they put their name on it. You also find, for example, stamps of the content of gold in, for example, artifacts that have been made, or silver. These are already elements of quality management, showing what the products were about. Now, the production, when we look back in the past, and most of the time, except for some examples, everything was still handmade. Handmade products are still loved by people today, but they are in fact unique products. And sometimes people don't like those unique products because they want to have a repetition of their experience. For example, when you want to have a hamburger, whatever chain it's making, they try to make the taste the same everywhere. Basically, people try to repeat the quality, and it's not handmade anymore. Handmade means that every product is unique and there may be variations. Sometimes I saw people complaining about handmade products when they bought two products and that they were different. Well, with handmade products, this is completely normal because those products are all unique. There are some differences, and the craftspeople who are making those handmade things, they may adjust the way they make something for different reasons. So basically, handmade is unique. Now, interchangeable parts already started to happen in certain eras. Eli Whitney was making muskets for the US Army, and it changed the way of making the muskets to win a contract. Originally, muskets were made by craftspeople. Those craftspeople made the entire musket. They did the work from A till Z, and they adjusted everything. Now, what Eli Whitney did was that he was splitting the process to make that gun, that rifle or musket, in a way that people started to be specialized in making certain parts. That also meant that when one person is making the barrels, the wooden holder for the barrel should also be made in a way that they fit together. So the barrel has to be controlled to be within certain specifications. Now, quality, we can already find it a long time ago. We've seen some evolutions. The first element of process production were the muskets by Eli Whitney, but basically the quality started when the Industrial Revolution began at the end of the 19th century, beginning of the 20th century. And we know examples like Henry Ford and other people who revolutionized production. So basically, we see that the real evolution, the start of what we know today, was in fact born at the time of the Industrial Revolution. When we look at the quality management in the industrial age, we see that we have to create those interchangeable parts. And in order to create interchangeable parts, we need to control these parts, the production of those parts, to ensure that all those parts can be assembled into the final product. People are making parts for an engine. Well, finally, the goal is not making the parts, but the goal is making the engine. So the people who are making the parts, like the pistons and the cylinder elements and all the parts that make an engine, they have to make it in a specific way so that it's possible to assemble the final product. We will come to that later. On the other hand, a very important evolution in the industrial age was in fact the mass production of cars by Henry Ford. The first, the Model T that was introduced by Henry Ford, was in fact a revolution. The fact that he changed the process, the way to make a car, revolutionized the entire car industry. And of course, we had to introduce, or the people had to introduce, statistical methods to measure the quality of the work that was done. So the more we knew about statistical methods, the more we were in fact introducing those statistical methods to control how the production was going. Now, it's very important when we are creating more and more products in a process way, we need a lot more control. So basically the quality control, because we are having a very large quantity of products, of components that have to be assembled, quality control becomes a very important element. And bad quality can create a lot of problems, not only internally in the factory, but also externally. I remember the story of my father where he was talking about a man coaching or training a younger man in the production of a car. And in one moment, the person, the older person, the teacher, left a wrench in a part, I think, in the engine of the car. And the young boy said, "Hey, sir, we have to take it out. We forgot it there." And the old guy said, No, it's okay. It's not our problem. It's a problem at the end of the chain. Of course, you can imagine, or perhaps not, starting an engine which has a wrench in it. It's not a real nice sound. And basically, the quality that was initially done at the end of the production line was still causing a lot of repairs, reworks, scrappings at the end, which could be in fact remediated at the process step itself. So basically, quality control becomes more and more important, gets integrated in the processes, and we see different types of quality management arising. A very important element is known as Kaizen and TPS, or the Toyota production system. Now, Kaizen was in fact not known until the 1970s, and it became only available, or people started to notice that there was something different when you bought a Japanese car, because their quality was of a higher level. Now, we all know the story about Toyota, Lexus. People didn't want to, or manager didn't want to drive a Toyota car. That's why Toyota made Lexus. But basically, they saw that these little Japanese cars, compared to European models, were of a higher quality, less problems, more reliable, and things like that. So people started to see that there was something new. And basically, together with Kaizen and the Toyota production system, new terminologies like lean management, just in time, just in schedule, 5S, 5Y, started to become available to the people. People started to understand that there are new tools that come available. So basically, these tools are part of the Kaizen toolbox of the people who are working in process management and are very important tools of Kaizen and TPS. Now, many people just think lean is just a set of tools that we use. And basically, when you read the books about Toyota, the Toyota production system, and so on, you will see that they consider lean as a multi-level philosophy. You start with the basis and you have a foundation, and then you have well-defined principles. And the combination of all those principles together makes, in fact, Kaizen, makes the Toyota production system. Now, Kaizen on itself means continuous improvement. And we will talk about continuous improvement later on, because the idea basically came from a great American guru, Deming, who made what we call today the Deming wheel. It's also an example of continuous improvement. Now, when we apply Kaizen in our production, when we apply the principles of lean management, we will see that it will reduce the quality issues, the quality is improved, and also the costs are reduced because we have a different way of managing the production. We go to what we call a pull production system, and we only have the parts that we need. We don't create any excess. Many American companies or Western companies were producing a lot of items. They were just waiting. And because of that, there was a lot of money in the production, money that took a long time before it came out, before you can sell the goods. And basically, defects were detected very late. So basically, the way of operating was creating not only quality problems, but also cost issues. The cash flow of the company, the more unfinished items you have, the more they can be damaged. And of course, the more money you need to keep on operating. Any financial guy can tell you, when they walk through a factory and they see all the unfinished goods, their heart hurts, because a finished good doesn't bring any cash to the company. Now, another item, another methodology that is in fact known is Six Sigma. Six Sigma was defined by Motorola. Motorola made this quality methodology, or developed it in the 1980s, and even took let's say a patent on it. Now here we look at the process quality, and the goal is to reduce defects and the variability of the processes. Now both of these elements are very important, because we will see later that variability, or we have seen it before in some other videos, but we will see that variability is not a very good element, and we have to reduce variability to increase quality. When we look at the Six Sigma process, we look at processes that have not more than 3.4 defects per million operations. We call it 3.4 DPMO. Now that seems to be a very challenging number, and over the years many companies have been implementing Six Sigma, trying to get there. It's not easy, it's a stepwise effort, it takes a lot of time, a lot of investment, but basically it's worthwhile. Now you can imagine that there are industries where 3.4 DPMO is not sufficient. Somebody told me, and I couldn't verify it, but for example, for certain parts at Mercedes, they allow only 1 part per million to be outside of the specifications. So basically, it's very important to understand how these things work, and Six Sigma will help you with that. Now, here we combine different quality tools to identify the problems in the processes. And there is a very well-defined quality tools set that we will describe in the following slides also. Now, the tools that we are typically using in Six Sigma is what we call DMAIC and DFSS. So we'll look at that in the next slide. Now, people who are working in a Six Sigma company, they're assigned belts which have a color related to the expertise of the person. Now, the idea comes from the Japanese sports like judo or karate, and you will see that there is a yellow belt, there is a green belt, and so on. So we will look at that, what those belts mean in the next videos. But first, let's have a look at DMIAC. And what we have here is a tool set where we have define. We define what is necessary. We measure how the actual process is working. We analyze the data. We look at cause and effect relationships, and we try to find out the root causes, and then we improve the process. So we find out what is going wrong. So we try to find out what can we do to improve the process, and of course we implement it, and then we control the output. We look at different control systems to see, did we do a good job, yes or no? And then we go back to the start until we reach the level that we would like to have. We also have the other element, DMADV or DFSS, and DFSS means Design for Six Sigma. We will talk about Design for Six Sigma. We will talk about design DFX, which means that we have a variable, we have different design for models, but the DMADV cycle is in fact a little bit different. We first define, let's say we look at the goals that are consistent with the customer demand and our strategy. Of course, we should never forget what our company strategy is. We measure the parameters that are important. We analyze it to develop and design alternative. We design an improved alternative following the analysis that we did in the previous step, and then we verify the design, we run pilots, we design and implement a production process, and finally hand it over to operations. So basically here we have a way to make a design, to start from the product definition, and how do we create that design that complies with this. So that's basically DFSS, or Design for Six Sigma. I spoke about the belt system and what they mean. Now we start basically from the right-hand side. I didn't put a yellow belt, but sometimes there is a yellow belt, which is in fact the basic level. The people are aware of quality management. They may have just had a course. So basically they understand what quality is about. But when we really start to go into the Six Sigma, we have the green belts, which are the people who are, let's say, working into the environment of Six Sigma. They implement in their job, and it's part of their job responsibilities. Then we have a black belt, so people apply Six Sigma over projects. They operated under what they call the master black belts. There is the master black belts, which are the in-house coaches, and they ensure that the Six Sigma application in the organization is in fact realized. There are also champions. They look at implementing Six Sigma across the entire organization. And it's very important when we look at Six Sigma that the executive leadership is in fact included in the quality effort. Without any support of the executive leadership, there cannot be an effective quality management, quality system in a company. Everybody has the same goal from top to bottom, from bottom to top, to create products or services that are in fact Six Sigma level quality. This was a little bit longer overview, about 20 minutes, about quality, the evolution of quality, the different quality models that we have. And now we can start with different elements. We can look into the basics of quality management, and we will do that in the next video. So you're doing a great job, and I'm looking forward to seeing you in the next video. Thank you, and bye-bye.